Okay, so good morning again. So let us start. Okay, so Maximilian, you want to ask a question? Yes, please.
So if we have that circle that we did, let's say that you give us 2 points which are known and 1 point which is unknown. Can you figure out that point with the 2 other points somehow?
No, because you have a lot of degrees of freedom. If you have a circle, there are infinitely many points on the circle.
Yeah.
Yes. And then even if I give you 2 points on the circle, how can I ask you about?
But what if they're like somehow related?
No, if somehow related, that relation should be clear. Then that would be a different story.
Okay.
Might be we can, or might be if the information is enough. Then if the information that you provide is enough, the answer is yes. The information that you provide is not enough, the answer is no. Yes, but I mean that just you tell me 2 points on the circle and you give me another point on the circle, can I find the coordinate of that point on the circle based on these 2 points? No. Because unless there is a relation between these points that you are choosing. Okay, so I hope that you learned what I told you before, but let me also calculate. So I told you that in trigonometry, as you realize, there are some famous angles. So one of them, so 4 of them we learned. What was that? What was them? What were them?
90, 180,
0, 90, 180, and 270. And of course, 360 degrees is also, it's good to know, yes? Because these are the geometrical angles that we face, so I would call them famous. But there are 3 more angles that are famous, not because nature cares about those angles, because we can calculate them exactly without calculator. So that is why they became famous in the first place. Okay, so those angles are 30 degrees, 45 degrees, and 60 degrees. So let us try to understand them. Okay. I think the simplest one is 45 degrees, if you want to find that, yes? So here, I am asked, so the question is this. I want to see, without calculator, if it is possible to calculate sine of 45 degrees, cosine of 45 degrees, and tangent of 45 degrees. Okay, so how should I do that? First of all, I need to find the end point that corresponds to 45 degrees. So what I have to do, so I go here, and then I draw a unit circle, x and y. And then I told you that this is the origin of my circle. So every angle that I am talking should start from this side. And then I start rotating. Here 45 degrees is positive. I rotate in the counterclockwise direction, which by convention is the positive direction. And then I will stop after rotating 45 degrees. So it becomes exactly the angle bisector here. Yes, do you agree? Because the whole angle is 90, and if I want 45, so that would be the angle bisector. So this becomes angle 45 degrees. And then what I'm supposed to do, I am supposed to read the coordinates there. Yes? So I would say that, okay, let me call this point B, and let us understand. So let me write x and y. We want to understand this x and y. If I can find x and y, then I am done. But that is extremely simple, okay? But before that, I want to remember something from the distance, from Math 2C, which is called the distance formula, okay? So do you remember what was the distance formula? If we have a coordinate system, y and x, if you give me 2 points, the coordinates are given x1 and y1, and you give me another point, coordinates are given x2 and y2. If I ask you, can you calculate the exact value of the distance between A and B, so let me call it D, you would say yes, that is the distance formula, which is actually the Pythagoras theorem, yes? Written in this disguised form. So this is square root of the difference of x coordinates squared plus the difference of y coordinates squared. This we learned in Math 2C. Of course, this is very, very simple. You just make a right angle triangle out of it. So then this length is x2 minus x1, and this length is y1 minus y2, And then you put them in this formula, you get the distance. And it is not sensitive in which order you are writing it, because there is an even power, so it doesn't matter. But anyway, if you want to find the distance of 2 points in the coordinate system, this is the distance formula. Subtract the x coordinates, square it. Subtract the y coordinates, square it, add them, and take the square root. That is the distance formula. Okay, but now let me take a little bit more interesting point. Let us assume that one of these points is the origin. Okay, so for example, let me take B to be my origin. I want to find the distance from A to O. This is my goal. Okay, so what is that distance? From O to A is equal to square root of what? The difference between x coordinates, which is just x1, because the x coordinate of O is 0, to power 2, plus the difference of y coordinates squared, so that is also y1 squared. So if I want to find the distance of any point on the coordinate system from the origin, I take the square root of the sum of the coordinates squared of that point. Yes? Is that clear or not? Okay, so let us go back here. When you say that x and y are the coordinates of B, if I ask you find the distance from O to B, on the one hand you know this distance. What the distance is? 1. Why? Because this is the radius of the unit circle, so it should be equal to 1. But on the other hand, you know something more. You know, according to this formula, if the coordinates are x and y, then square root of x squared plus y squared is OB. So OB is 1, it is clear. But on the other hand, OB can also be calculated using the distance formula. It is supposed to be 1. Yes? And then what happens, I want you to remember this. X squared plus y squared is equal to 1. Sometimes might be they ask you what is an equation for the unit circle. That is an equation for the unit circle. Every point, not just this point, every point that you find on this circle, its distance to the origin is equal to 1. So it is always true if you have any point on the circle. Yes, not just this point. Any point that you pick up on the circle, the x coordinate of that point is squared, plus the y coordinate of that point is squared is always equal to 1. Is that understandable or not? Okay. Now let us go back to this scenario. I want to find x and y for this particular case. This was not for this particular case. This is always true, but now I want to find x and y for this particular case that the angle is 45. Okay. So what can I say? On the one hand, I can say that x squared plus y squared is equal to 1 because this is always true. But for this scenario, if I draw this vertical line, if I ask you what is the length from here to here, it is easy. You say the length is x. If I ask you what is the length from here to here, that's also easy. The length is y. But on the other hand, what is the relation between x and y in this case?
They are equal.
They are equal. Yeah? So x is equal to y. So I am looking for x and y. On the one hand, I know x squared plus y squared is supposed to be 1. On the other hand, I know that x and y are equal. So I set up a system and try to solve it and find the x and y values. But solving this is a very simple, yes? Because you are telling me that x and y are equal, I write x squared, but instead of y, I write x, it becomes x squared equals to 1. 2x squared is equal to 1, yes? X squared is 1 over 2. But I want to find x, so x is plus or minus 1 over a square root of 2. But for this problem, which one is acceptable? Or both of them? Of course, both of them cannot be acceptable because that is 1 point. Which one is acceptable?
The positive one.
Because you see that 45 degrees end up here, and here the x-coordinate is not negative. Yes? So this means that I have to choose the positive one. So x equals to 1 over square root of 2. And if I tell you what is y, y is the same. Okay, now let us answer the question. Now that you know x and you know y, you can answer these questions immediately, yes? So what if I ask you what is sine of 45? Do you remember sine of 45 is the y coordinate, which is 1 over square root of 2. And if I ask you what is cosine of 45, cosine of the 45 is the x coordinate, which if I ask you what it is again the same number. And then if I ask you what is tangent of 45, it is the y coordinate divided by the x coordinate. But because these two are the same, so the tangent becomes 1. So we know from now on that sine, cosine, and tangent of 45 degrees are these numbers. The reason that they are famous, as I told you, is because we can calculate them without any troubles. Okay, for 30 degrees and 60 degrees, it's a little bit more tricky than that. For example, let us concentrate on 30 degrees, okay? Let us see how it goes. But still, we can do the calculations precisely. So let us consider this the unit circle. I want to answer this question this time. What is sine of 30 degrees? What is cosine of 30 degrees? And what is tangent of 30 degrees? By the way, do you remember I told you that if two angles are added to 90 degrees, they are complementary angles, and then we learned a remark last time. It's the sine of one of them is equal to the cosine of the other one. That's also possible, so I didn't need to calculate cosine. Because 45 is complement to 45 itself. So sine of 45 should be equal to the cosine of the other angle, which is also 45. So that was also predictable here. Okay, now for this one, I have to do the same thing more or less. But this time I have to rotate 30 degrees. So if I rotate 30 degrees, it is a little bit lower than this bisector. So let us consider that this is 30 degrees. But somehow, this is point B, and these are the coordinates. I don't know them, I want to find them. But one relation I know, of course I know that x squared again, plus y squared is equal to 1. So x squared plus y squared measures the distance somehow to the origin, and it's 1. Okay, but I cannot immediately guess what x is, what y is, because x and y are two unknowns, but I have only one equality, so I need something more. So I need to discover another relation so that using those two I can find x and y. So what can I do here?
Isn't the length of OB still equal to 1?
Yes, always.
Then why can't we do the same thing as we did on the other?
No, because we don't know what is the relation between x and y. I have written this already, but that is one piece of information. Another piece of information we need. So what can we do? We can do some kind of symmetry, a little bit tricky argument. So what I do the mirror image of this one. Let us see which way is better. Yeah, this way is better. So I will make the mirror image of this with respect to the x-axis, and it becomes another point here. So let me call it point C. Yes, and then connect it here. Okay, so how much will this be? 30 degrees from magnitude point of view. But of course, if you want to say the sine, it becomes negative 30. But from size point of view, this is 60. Yes, but what type of triangle will this be then?
Isosceles? No.
No, more than isosceles is always,
Equilateral.
because this one is equal to that one always, because this is the radius, this is the radius.
Is it equilateral?
Equilateral, because it is our isosceles, OB is equal to OC, but on top of that, this angle is 60. So it means that it should be equilateral, yes? So it means that all these angles are actually 60 and 60. So this is, the point is that the sizes are all the same. But, so let me write this more properly. So OB is equal to OC is equal to BC is equal to 1. Because OB and OC are radii, so they are already equal to 1, but I also showed that BC has to be equal to 1 as well. Okay, then it becomes extremely clear. So can you tell me at least what y is? What is y? Y is this length. Yes, so what is that? How much?
0.5.
Yes, why? Because the whole BC is 1,
Yeah.
so this one is half of it. So the y coordinate, so this means that the y coordinate is 1/2. But now I know that x squared plus y squared is supposed to be 1. This is always true, independent of my point. So x squared plus y squared is equal to 1. I already know what y is, so I would write x squared plus 1 over 2 to power 2 is equal to 1. So x squared plus 1 over 4 is 1. I move this to the other side, it becomes 3 over 4. Then it becomes plus or minus the square root of 3 divided by 2. But of course you see that 30 degrees is still in the first quadrant. And in the first quadrant, x cannot be negative. So at the end, you would say that x is only one value, and that is this value. This is x, this is y, and then now if I go back and ask you the question, you immediately answer that. So what is sine of 30? Is the y coordinate. The y coordinate is 1/2. What is cosine of 30? Is the x coordinate, square root of 3 over 2. And then if I ask you what is the tangent of 30, you just divide this number 1/2 by this number, square root of 3 over 2, and then this and that are cancelled. You get 1 over square root of 3, yes? Yeah. But let me also, some books, I don't know what is the convention in your book, I think, that usually people prefer to not have surds in the denominator. This is not wrong, but let me go back and write it with a different color. That number is exactly equal to this number. So that number is also exactly equal to that number. For the same reason, this number is also exactly equal to this number. Why this is true? Because you can, so let me just do one of them. If I have 1 over a square root of a, not 2, not 3, any number, I can rescale it by the same surd. Yes? And then 1 times square root of a is square root of a, square root of a times square root of a is a. So remember this, always you can write 1 over square root of a as square root of a over a. On the other hand, you can also understand it from this perspective. This times that is equal to that times this. So this is somehow you see in some books. So I myself sometimes prefer to use this, sometimes I prefer to use this, depending on the context that we are working. But I really don't need to do anything with 60 degrees. It is automatically clear. Why? Yes?
If we are angle 60, then the length is always the same. That means
No, another reason. 60, please respect to this because it's important. 60 and 30 are complementary. So sine of one of them is equal to the cosine of the other one. So I really don't need to do the calculations anymore. So what I can say is that if I ask you what is sine of 30, sine of 60, you should be answered to this immediately. Sine of 60 is equal to cosine of 30. So it is the square root of 3 over 2. And cosine of 60 is sine of 30. It's 1 over 2. And then tangent of 60 is a number so that when multiplied by this it becomes 1. So it is the reciprocal. It is the square root of 3. Because the square root of 3 times that number, it becomes 1. So you really don't need to do everything from scratch. Use that remark. Okay? Okay, so you will have that table. So I will draw this table for you quickly. And you will get this table. So let us just put the information that we need here. So I have this theta, sine theta, cosine theta, tangent theta, and the angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180, 270. Oh, let me also add 360. These are geometrical angles that we can calculate directly, okay? So if you combine what I just got here and what we did in the morning, these are the numbers. So this is 0, 1, 0. We just got this is 1/2. This one is a square root of 3 over 2. This one is 1 over square root of 3, which can also be written in this form. This is 1 over square root of 2, which can be written in this form. This is also the same number, which can also be written in this form. And this is 1. And then this is the other way around. So the square root of 3 over 2 goes there, 1 over 2 here, and the square root of 3 here. And then you have 1, 0 undefined. And then we have here 0, minus 1, 0. And then here you have minus 1, 0 undefined. And then here you have 0, 1, 0. So this you will get in the table, I think, in the formula sheet.
We get this.
Yes.
Okay.
Or hopefully I can check that. Let me see.
Please do.
Now we have the paper here, so what is this one? It's Math 2. Or Math 3C if I have it. Yes, you get the table here. Even, I don't know, this is a little bit strange. You get even some bonus.
Really?
Yes, you get also 120, which is strange. You also get 135 and 150. But you will not get more than 180. So you get something up to here. But that is good. This is, I want you to learn because that is also important. Okay? Okay, so I didn't know, by the way, that you get this. I was thinking that they should ask you to calculate sine of 120 degrees, but anyway. But let us now calculate sine of 120 degrees. You really don't need to calculate if you took my recommendation seriously this morning. So how can I calculate sine of 120 degrees? Because if you are not allowed to, if you are allowed to use a calculator, no problems, but just punch it there. And I think Casio calculators are much better because they will give you exact values. I didn't find any way to do it in Texas Instruments, so that's a little bit strange. Or might be you should to do something to get the exact value. So I think if you have a Casio calculator and you punch it here, you will get the exact number. For example, tangent of 30, you just put it in the Casio calculator, you get exactly square root of 3 over 3, or this one, exactly, not with decimal points, hopefully. Yes?
The sine of 120 is same with the sine of 60.
Yeah, exactly. So that's what I'm saying. So I mean that you really don't need, you have to remember the remarks. Those remarks are extremely important. So if you ask me sine of 120 degrees, of course you have it in your table. But even if you didn't have it, you could calculate it yourself. Because 120 is the supplement of 60. And we learned that if two angles are supplementary, the sines are exactly the same, but the cosines are opposite and the tangents are opposite. So this means that if I ask you what is sine of 120 degrees, you just say that sine 120 degree is exactly equal to sine 60 degrees because they are supplementary. And then I can read it from the table here. It is square root of 3 over 2. But if I ask you what is cosine of 120 degrees, then this is negative of cosine of 60 degrees. There is no way that you should forget about this. So please memorize these two important rules that I mentioned as a remark. Supplementary angles, complementary angles. So this becomes minus a half. And then you remember I also talked about tangents. They are also opposite. So of course, now I realize that these are also given to you in that table. But remember, 270 is not given, 360 is not given. But that is easy to visualize, yes? But if you ask me what is sine of 121 degrees, then I cannot answer. Because there is no angle here that is supplement to 120 degrees. 59 degrees. I don't know 59. But I can say that sine of 121, whatever it is equal to sine of 59. But I cannot answer the exact value. Okay, so I think that this is now understandable for every one of you. Yes?
If you had 390 degrees, could you just say it's the same as the second?
Yeah.
Like
So
that?
everything we talked in the morning was the important core of this lesson. So whatever you can use, for example, as he mentioned, for example, if I can ask you what is sine of 750 degrees. So what is that? And that is one important part of the lesson. They give you this table, but they might ask you sine of angles that are not included. So that is the whole point, that you learn how to do it. So where sine of 750 degrees end? So I start from here, rotate one full round, it is 360, it is not enough. I go another round, it is 360 degrees, it is 720, so far it is not enough. So I have to go 30 degrees more. So there is no difference between this one and 30 degrees because the final points are the same. And then you can read it from here, yes? But whatever you can do. So you have to have this imagination in your head and then try to use it in an effective way, the proper way.
And Baba, and I imagine if the numbers were negative, like negative degrees, it would be the opposite way, right?
It becomes the opposite way, but it doesn't matter because even if you go in the opposite direction, you end up somewhere. Yeah. So for example, here you could ask, what is sine of, I don't know, minus 750 degrees? But then, what happens, by the way, that's also a good question. Of course, this is a little bit tricky. Let us just do that. So sine of minus 750 degrees, okay? This is, I would say, a higher level question because what you do, you can draw this circle and let us locate where is minus 750. Where is it? I go in the opposite direction here, one, but another one, but with more 30 degrees. So I will end up here. Yes, which this angle is minus 30 degrees. And then the point is that, don't forget the point. If you want to answer this question, there is one thing that you have to answer. What is the y-coordinate? Of course, the y-coordinate is positive or negative in this case? Negative. Clearly the answer should be negative. But the point is that if you are not allowed to use the calculator, which in one part of the exam you are not, the only thing that you have is the formula sheet. You should have it. You have it all the time with you.
Yes.
So you should be able to use the information here to be able to answer that question. So I would say this is a level 2 question, yes? Level 1 questions are something like this, but level 2 questions needs a little bit of concentration here. So you need to decide which one of those angles are somehow related to this end point. So which angle do you think it is?
30 degrees.
Might be 30 degrees. That's a good guess. Let us check. So where is 30 degrees? 30 degrees is here. Yes? If I ask you, can you tell me the coordinates of this point using the table? You should say yes. What are the coordinates? You have sine of 30 degrees, how much? 1/2. Look at that table. So this means the y coordinate of this point is 1/2. If I need, in this case I don't need, but let me write. What is the x coordinate? It's cosine. Square root of 3 over 2. But from this point, you need only the y coordinate. But can you tell me, if I know this, what is the y coordinate of this point? Mirror image of that?
Is it -1/2?
Minus 1 over 2. So the answer to this question is minus 1 over 2. Yes? Is that clear?
Is that a general rule? That
Yes, I want to talk about the general rule. I think it's not in the book, but let us talk about the general rule. It's not that hard. So we want to talk about this scenario. What happens if I want to calculate sine of minus theta? And what happens if I want to calculate cosine of minus theta? And the same question, what happens if I want to calculate the tangent of minus theta? Let us answer these questions, yes? So, for example, let us assume that this angle is theta. Of course, there is no guarantee that theta is small, it might be hard, but you can imagine that the argument will remain intact if I want to use this argument. Okay, so this is my theta. But where is my minus theta? Minus theta would be the mirror image of this point. I hope that you agree with me that this angle is the same size but in the opposite direction, so I can call it minus theta. Now, let me assume that this one has x and y coordinates. Now, can you tell me, if the coordinates of that is x and y, how do you read the coordinates of this point? X minus y. The x doesn't change, but the y coordinate becomes opposite, yes? And now I'm asking you the question. If I ask you cosine of theta, you will tell me cosine of theta is the x coordinate of the final point of theta, which is x. If I ask you the same question for cosine of minus theta, you would say that I will go to minus theta, find the final point, and read the x coordinate, which is again x. So this is a very nice relation. Memorize it, by the way. Cosine of minus an angle and cosine of the angle are exactly equal. So the cosine absorbs the minus sign. It will destroy the minus sign. Okay, so that is a very important rule for cosine. But now let me ask you the same question for sine. If I ask you what is sine of theta, you go to the final point of theta, read the y coordinate, put it in front here. And if I ask you the same question for minus theta, you go to the final point of minus theta, read the y coordinate, which you put it here. But are they equal? No. But they are opposite. Yes? So this means that sine of minus theta is not equal to sine of theta, but minus sign goes out. It's extremely important relation. So if I have sine of a minus angle, I can simply put this minus sign out and then write this. Yes, Hussein?
Can you just remind me how the inverse cosine works? Because it's very confusing having the negative in the sign. Isn't it related? It's not related to the inverse cosine. Inverse
No, no. No, this one is not related
Not
to the...
okay.
Okay, and then what happens for tangent, by the way? So let me just do tangent in a different way. Tangent of any angle is equal to the sine of that angle divided by cosine of that angle. Yes? This is the tangent of any angle, not just minus theta. But we just learned that for sine, minus sign goes out. For cosine, minus sign is completely gone. And now if I ask you what can I write instead of this part, you say this is just nothing except tangent, but there is a minus sign left. So it's minus tangent. So the rule for negative angles for tangent and sine are the same. The only exception is the cosine one. Cosine will actually get rid of that minus sign, gets rid of that minus sign. Yes? So this is good to know in general. Okay, so I don't want to actually try to put a lot of information in today. I want to give you a little bit of time to practice as well. So there's one important thing left, which I really don't like to teach it at this point, but I have to because it will be one part of the national exam, okay? Because we will repeat everything again, that part in Math 4 as well. This I don't understand why we have to do it 2 times. One thing that I want to answer, first of all, do you remember I told you that there is something that I cannot describe it right now in the sine rule and cosine rule? I will describe it later. Let us understand it now, because you know you have the tools in your hand to understand. Let me start with this question. I want to ask your opinion about this. For example, I give you this picture, and now I go back to your Hussein question. Actually, this is the inverse question, but I want to ask you here now. So, for example, I give you sine of theta is equal to 1/2. Okay? Either you have your calculator with you, or you have this table in front of you. You can answer what theta is. For example, let us use the table, or if you want, you can punch this. If you want to punch this in your calculator, you should say theta is what? Sine inverse of 1/2. And then if you do it, you get exactly one answer, not 2 answers on your display. And then if you read this table, it is how much? 30 degrees. Because sine of 30 degrees is 1/2. But do you remember I told you that there's another angle that the calculator will not show to you? Now you will understand why. The reason is that when you say that sine theta is 1/2, it means that you are looking for a point whose y coordinate is 1/2. But it is also on the unit circle. If I ask you find a point or all the points, do you think there is only one point or more than one point with this property? More. So one of them is where? So you see, you take your ruler and measure 1/2 on the y coordinate, and then you draw a horizontal line, and then this point and that point are your points. Yes? If I tell you this length is 1/2, if I ask you, can you tell me the coordinates of these points? You say that I might not be able to give you the x coordinate, but the y coordinate is 1/2. The y coordinate is also 1/2. Okay? Now look. The calculator only gives you this acute angle. 30 degrees. Okay? But you see there is another point whose height is 1/2, which you don't see using calculators. The other angle is how much? Can you tell me from where to where? What is the other angle?
150.
How do you know? You have to start again from here up to here. So, but what that angle is? It's 150. Yes? And that was the reason. Do you remember I told you memorize this for the time being, but you will learn what later. That is now later time. Yes? So if I ask you what is sine of theta, what is theta if sine of theta is supposed to be 1/2, you have to answer me two angles. One of them is the one that you get from the table or from the calculator, but you need to understand there is another one, which is the supplement of that angle. This is one point. But to be honest, are these the only angles? These are the only points. But are these two angles are the only angles or not? No. So I want you to appreciate the difference between them. If I ask you, give me points on the unit circle whose y coordinate is 1/2, there are exactly 2 points, not more. But if you tell me what are the angles, I would say one angle is 30, one angle is 150. But how many angles are there so that the sine of them is 1/2? Yes?
Infinitely many, I think.
Infinitely many, yes? Because this is 30, I can start rotating one full round back, then 30 turns into 30 plus 360 degrees. This is a new angle, but I will end up at the same point. So 390 is also an angle whose sine is exactly 1/2. You can check it with your calculator. So it means that if I ask you write all the numbers, the other one is how much? I say that 330 degrees, but instead of going one full round, I can go two full rounds, yes? But I will return to the same point, so the sine is the same. So you can say that, okay, theta is 30 degrees plus any multiple of 360 degrees. Any integer multiple of 360 degrees. That would be the topic of the next lesson. I will teach it more formally later. But at least I want you to understand, if someone tells you find all the angles, that is one group of angles, but it is not finished. All these groups are for this point. But we also have another scenario here. So I can say that, okay, theta is 150 degrees plus any multiple of 360 degrees again. So I have used n already, so let me choose m this time. It doesn't matter. Some books, they write the same letter even. Okay. So then this is completely determined. So there are infinitely many trigonometric angles whose sine is equal to 1/2. But there are two main ones, if you like to call them main ones, 30 and 150. But how many more are there? Infinitely many, yes? So this is the next lesson that I will teach you. This is called a trigonometric equation. If I ask you find theta, it means that you are facing an equation. And then if I ask you find all possible values, which when I say solve, it is implicit in the word solve, then what I expect you to write is this. Yes?
What if the question was find the value for theta?
No, that is not correct. They cannot ask you the value.
There's no
the
specific
value. Yeah.
Okay. Yeah.
But I can say I myself prefer to call these two the main angles of interest. Yes? Because usually these are the two angles that we are interested in, but I just want you to know that there are infinitely many more. Yes? But from the perspective of the unit circle, there are not infinitely many points. There are exactly 2 points corresponding to all those angles. One of them is here, the other one is there. Yes? Any questions? Okay. So I would do that. Definitely we will finish next week, but I want to finish before Wednesday, so I don't know if Sima is going to give me another lesson from her, but if you convince her, I probably can do. Otherwise, I will finish on Monday, and then we will practice on Wednesday and the next Monday. And I will go through the national exam, and if you have questions, you can also bring it in the lesson to see how it goes. And then Tuesday you will have the exam, okay? I checked. I think the volume is not included. So the Origo book, for some reason, they were talking about the volume. So I don't know. But in case, if there is a question that I haven't taught, I will go through them because I don't know the questions yet. I will see them, I don't know, the day before or 10 hours before that. In that case, if that's the case, don't worry. I just said don't answer that question, and I will break the points to the other questions. Okay, but I don't think this will happen. Yes. It doesn't mean that if you don't know, I have to drop the question, yes? If I agree that I haven't taught that, then I will drop the question. Yes.
So
No, I shouldn't record these things.